Happy to see quite a few people here, and I hope it's going to add up once people come from the morning keynote. So this is the first session. We have 4 full papers, and each will have 15 minutes plus 5 minutes questions and answer. And the theme for this morning session is augmented and virtual reality in the real world. And the first presenter out today is Adalberto Simeone from Portsmouth University in the UK. And he's presenting work he's done with colleagues at Lancaster University on substitutional reality. So, Alberto, I'm happy to...
Thanks for the introduction, Morten. So, the talk I'm going to give today is about our novel vision of virtual reality. Indeed, I think if we have to choose a field within computer science that most readily evokes the idea of the future, then I think it must be virtual reality. But when I was younger, the future of virtual reality looked like this, or perhaps something like that. Unfortunately, 20 years later and a PhD later, I realized that we are still very far from the idea of a virtual reality that is undistinguishable from a real world. And indeed, the best way that we can have to experience virtual reality can be through state-of-the-art virtual reality laboratories, but the gap to this sort of ultimate display is still very wide. And if we think about experiencing VR at home, then we are still very far behind, because in a domestic settings there are a lot of objects that are not part of the virtual experience. And this has made it so that we can only experience VR at home while sitting at the desktop and while interacting with traditional input devices. And so we asked ourselves, how can we improve this experience of virtual reality at home? And the way what we investigated is if we could find a way to incorporate physical objects in the VR experience. And indeed, this is the core concept of substitutional reality. We associate every physical object to a counterpart in the virtual world, such as a chair, desk, or laptop, to another object in the virtual world. However, the main distinction from past work on passive haptics is that we explicitly assume the existence of a mismatch. Indeed, if there was no mismatch at all, then we would be very limited in the range of virtual worlds that could replace the physical world. We would only be limited to have virtual worlds that are exact replicas of the physical world in which we live in. And so we investigated what kind of possible substitution types we could conceive, and we created this model which starts at the bottom at the replica level, where the virtual object that replaces the physical one is an exact one-to-one replica. And then begins the alteration. For example, we could change the material of an object. If we think about a mug, a real mug, then at this level, the object that replaces it in the virtual world could be of a different material. For example, instead of a glass mug, we could have a plastic one. Then we begin to introduce or remove feature from the original object. For example, the object could be bigger or smaller, or have or lack some details. Then we have functional mismatch, when the affordances that are suggested to the observer about the original object begins to differ from the ones that are portrayed by the virtual object. For example, a box that replaces another object in the physical world might be opened in some way, but in the real world it might be opened in a different way. And then at the last level, we have a categorical substitution, when the two objects have no connection at all, save for the space they occupy, for example. So the higher we go, the range of objects that can replace the physical ones begin to increase. And we wanted to investigate which of these factors had the most impact on the suspension of disbelief. And so we designed an experiment in which we asked participants to interact with various substitutive objects. So we choose a real mug, like the one, well, this is the virtual version of the one we used, and we created various examples of substitution. So this is for the replica, of course. This is a one-to-one replica of the original object. And then we exemplified the aesthetic kind of substitution, where we created two mugs, one made out of glass and one made out of wood. We also wanted to investigate the effect of a material suggesting very extreme examples of temperature. So we created one made out of ice and one made out of molten rock. And then we created a smaller or bigger version of the original mug. We also created a combination of those factors, for example, an oil lamp, which suggests different affordances from the original object, because we can pour liquids into both the mug and the oil lamp, but we will not drink from the oil lamp. And also the basket can be manipulated similarly to the original mug. And finally, we have examples of categorical substitution, where the mug was replaced by a sphere or a box. So our goal was to investigate what happens when this mismatch increases, and the effect on the suspension of disbelief and how easy it was to interact with these objects. So we created a mock living room in one of our laboratories. We placed a sofa, desk, and cabinet, and TV. And we created a virtual environment that looks like this. So you should notice some resemblance from the original loom. For example, the wooden bench replaces the sofa. The crates are arranged in the same shape of the original desk. Then the barrel replaces the cabinet. And the wooden beam in the back replaces the TV stand, for example. And the fences at either side of this courtyard delimit the room in which we were. And so we asked participants to wear an Oculus Rift and sit on the bench there. And we asked them to interact with these two objects. We also had a wine bottle that was also tracked to simulate some more complex interaction, for example, through pouring liquids, for example. We asked each participant to interact with this object for at least 1 minute, and then we asked how similar on a scale from 1 to 7 they were in terms of size, shape, material, temperature, and weight. And we also asked how likely they were to believe that they were actually manipulating the object they saw through the HMD instead of the real one they were holding. They did not know what objects they were holding. And also how easy it was to manipulate the object, considering the overall mismatch from what they saw and what they held. In terms of quantitative result, I will go very quickly because there's a lot more detail in the paper, but very quickly. So, of course, as it might be expected, some material were easy to notice the difference. But it's important we found that the graphic rendering of the material is unambiguous, because if the participant, if the users, they don't have a clear idea what the material is supposed to be, then they might have different expectation. For example, if they think that it's made out of plastic instead of glass, they can have different expectation. And of course, also the temperature was easy to spot. But for example, one participant commented that if they were wearing oven mittens, they might have believed that they were holding the hot mug, for example. And in terms of the bigger one and the smaller one broke the illusion because participants touched the real object before they actually saw their virtual hands touching the small mug, whereas the bigger one was easier to believe. And in terms of the lamp, we found it to be believable, and we think this is because they can be manipulated similarly, but I will return this a bit later. So this is for the first study, and we also did another study. So please raise your hands if you have a lightsaber at home. Oh, I'm very happy to hear that. I have also 2 lightsabers at home, but probably I'm not an average person. But this raises an important issue, because if you think about it, if you imagine that in the near future we could experience virtual reality games or activities at home, it's easy to imagine that they could let us interact with objects that are very impractical to have at home, such as a machine gun, or maybe they don't exist at all. So if we found that the only way to have an interesting experience was to use actual replicas of those objects, then we would be forced to create props for each object. It would be easier if you could find that we could use another object to still have an interesting experience. So we designed another experiment where we wanted to know whether substitutive objects could engage users as well as replicas. So we created another virtual environment that looks like this. You should be able to also see some resemblance. This is supposed to be the bridge of a spaceship. And we asked participants to stand in a particular spot of the room, and you can see this moving object, and they were holding they saw in the virtual environment that they were holding a virtual lightsaber, and we asked them to hit this moving target with a virtual lightsaber. But differently from the first experiment, we kept the appearance of the lightsaber constant, and we changed the physical object they were actually holding, which they didn't know. And we varied between 3 different physical objects. One-to-one Force FX replica of Darth Vader's lightsaber, and 2 more common objects, such as an umbrella and a torch. So this is what it looks like from the perspective of a participant. They had to hit this moving target a number of times with each physical object. In terms of quantitative results, we found that it was very difficult to guess what kind of physical object they were holding. Indeed, more than 70% of the participants they were not able to guess correctly what kind of object they held. But overall, we asked participants to rate on a scale from 1 to 7 how engaged they felt to use each object. And we found that the torch was to be as engaging as the replica. And indeed, it was also the most preferred one, and it was found to be less tiring. But we didn't find any difference in terms of completion times. So in order to put all this together, we collected our observation, and based on our interviews with the participants, we collected a set of design guidelines that might be useful for future designer of substitutional reality experiences. And we found, for example, in terms of functional substitution, that participants found the experience of interacting with the oil lamp, for example, more believable when they were approaching the object from one of the handles. If you remember, we had a mug that had one handle, so on one side of the oil lamp, the correspondence was exact. So participants who touched the object from that side, they found it to be more believable. And this might also be the case for the reason why the torch was found to be more believable, as engaging as the replica, because the handle, the hilt of the torch looks like the hilt of a sword, of the lightsaber. And this could imply that it could be better to minimize the mismatch in the parts that are more likely to be interacted with the user. If you think about a sword blade, we are probably more likely to touch it from the hilt and not from the metal blade. And this could imply that we could increase the mismatch in the parts of the object that are least likely to come in contact. And regarding the materials, we found that it's important to communicate clearly what kind of material we are using. Otherwise, the expectation of the user will vary depending on which material is used. But this could also be used as an advantage from the designer. For example, if we have an object and we know how heavy it is, we can choose a material according to the real one. For example, if a box is heavy, we could use a material that suggests heaviness, such as iron, whereas if the box, for example, is lighter, then we could use tin, for example. This could also be used, for example, to give users superhuman abilities. If you think about a substitutional reality game where children play the role of a superhero, we could replace pillows for heavy boulders, for example, because in the role played by the children, they would have superhuman strength, and so they could be able to throw pillow at enemies, and the illusion would be corroborated. We also asked participants to rate their sense of presence on the standard SUS questionnaire, but we didn't find any significant difference. However, by interviewing the participants, we found that they felt the first environment to be more believable, because some participants, they said they actually had been in an environment that looked like that, whereas nobody has yet stepped on the bridge of a spaceship, so they didn't know what to expect. And this could be important from a designer's perspective, because if we are simulating environments that are based in reality, then we have to pay more attention to what the environment looks like and how it works, whereas we could have more creative freedom if we are simulating a fantasy or a science fiction-based environment. But substitutional reality doesn't stop here. We are working on future directions. For example, in this experiment, we focused on the mismatch between physical objects and virtual objects, but it could be interesting to apply the same concept to larger environments and larger architectural features, such as walls, rooms, doors, and see what happens where we move in such an environment. Then the ultimate goal would be to create substitutional reality system. Indeed, in this work, we altered the environments manually based on the actual measurements. But ultimately, it will be interesting to create systems that, based on the given input, are able to create and adapt a virtual environment. This also raises an important design questions, because if we want experiences to be designed before they are actually deployed in the physical environments, the designers will not have any clues as to which room they will be actually portrayed in. And we want the experience to be the same across a different range of physical environments. So we need to find ways in which to convey this information and design virtual environments in an abstract way. Okay, so this is solved. There's also a workshop paper that we recently published at a workshop at IEEE Virtual Reality, which discusses in more detail some of those future directions. So thank you for listening. I'm ready to start. Thank you. Okay.
So, if people will stay for a longer time in this environment, do you think that, what do you expect to be the effect? The good and bad?
Yeah, well, this is also being investigated in other research, but I think that technology is constantly improving, and so we are thinking about how VR might be experienced, not tomorrow, but in 5 years from now. And so we hope that eventually this problem, if not completely eliminated, will be at least mitigated.
Right. And the second question would be, you talk about kids throwing pillows.
Yeah.
I'm sure that's part of how you grow up, and if you get into school, you may learn about science and worlds that exist or didn't exist in the future, we don't know, or about dangerous animals. How do you think that such environments can serve education in schools?
Yeah, I think that this could be also applied for educational purposes. Indeed, for example, we could imagine museums creating rooms for substitutional environments where props can substitute items from a different age or epoch, so that we could have hands-on experiences. For example, I described in the paper the example of a Roman villa that substitutes a made-up room where we can use utensils from Roman age, but in reality we are touching objects that look similar, but of course aren't the real Roman objects they used, and to understand how Romans cooked food, for example. So I think there could be a lot of educational applications for this. Thank you.
Hi, Yan from Intel Labs. Really fascinating work. Thank you. And I have a question about the environment, because mostly the objects are sort of the smaller scale props in your study. What if that the environment, say somebody moved the coffee table, and so if you didn't track this environmental changes, will that break that kind of suspension of disbelief?
Yeah, I think so. Indeed, the object that the users could manipulate were all tracked. We tracked the user's hands and the mug and the wine bottle or the lightsaber. but a real application would have to track in some way object that users expect to move. So we could either choose which object we want to be interactive in the experience, or if we imagine the future where object recognition is easier to do, then that might solve the problem.
Okay. Hi, Yupeng Zhang from University of Toronto. In the example of the lightsaber, I never expect that we will have some real weight in the blade part of the lightsaber. Do you think that users' behavior or their feedback will change if you change the lightsaber in virtual world to some more solid Japanese sword or something else?
Sorry, what do you mean? If we change the object, with what?
Yes, because the lightsaber itself gives the user the image that it already have the weight of the handle, but the blade part is pure virtual and made from light.
We don't know about that.
Expect that it have weight.
Only George Lucas knows if it weights or not. All right.